Thank you very much. Good morning, everybody, and I'm delighted to be here on behalf of EFSA to introduce this topic, which is obviously also very high on the agenda, on our work agenda in EFSA. So I will try to explain a bit what we've done in the area of antimicrobial resistance, in risk assessment, and also in monitoring activities over the last 10 years. So as most of you, I'm sure you know, in EFSA we are responsible for conducting risk assessment on food and feed with the purpose to enhance food safety in the EU. And in the area of resistance, this translates in three different activities. We provide scientific advice, mainly to European Commission, occasionally also to European Parliament and to Member States directly, and this is normally in the form of scientific opinions. Quite often we also are asked to provide scientific and technical support, and this is very important every time there is a new monitoring activity that needs to be established. So we work on drafting technical specifications, which in turn gives information, valuable information to Commission to put together these activities. And we conduct every year, as you will see later, data collection at European level on antimicrobial resistance. And last but not least, we also are very active in communication activities, and we have been paying much more attention recently also to raising awareness and explaining better the outcome of our work. So the first part of my talk will be centered about risk assessment. So I will explain a bit of the historical work we've done. As I mentioned, we started already almost 10 years ago with the first mandate on antimicrobial resistance and the food chain. And I will briefly explain also a couple of ongoing mandates that are about to be finalized in December. So back in already 2007, quite a long time ago, the Biological Hazards Panel thought that this was an emerging issue, and they had the idea to launch a self-task to try to determine what was the level of exposure to antimicrobial resistance bacteria via food. The attempt was to do this quantitatively, and it was very quickly apparent that this is a very complex question and that it's very difficult to put a number to it. Nevertheless, over the years it has been proven that it doesn't really matter. This number is not really crucial, since, as we heard this morning from the several speakers, this is an ecological problem and everybody really should contribute and do their best in their own independent areas. I think the old habit of blaming each other, from vets to doctors and vice versa, is something that has been left in the past. Therefore, we're not at the moment that concerned about putting a specific number to the problem. What was clear and is clear today is that foodborne bacteria display an increasing and diverse range of resistance to critically important antimicrobials, and specifically to those which are last resort antimicrobials to treat human infections, such as carbapenems or colistin. And that any further spread of resistance in bacteria from foods will have an influence on human exposure. How big this influence is another matter, but for sure it will have an influence. Shortly after, again, there was a mandate received, and in this case the mandate was answered jointly by ECDC, EFSA, EMA, and a non-food committee, a senior committee, and it was the messages were quite clear that antimicrobial resistance at the time in 2009 already was increasing, and it was more and more difficult to treat human infections. We were asked to do a priority list of microorganisms and antimicrobials, and at the time Salmonella and quinolone resistance and Salmonella and cephalosporin resistance, followed by Campylobacter resistant to quinolones and to macrolides, were identified as the top concern antimicrobials and microorganisms. It was a very clear message that the use of antimicrobials is the main factor driving the emergence of resistance, so there is absolutely no question about this. And that the very different situation in different member states makes it difficult to have a single strategy to fight the problem. And we have seen in recent years that the fashion is really to ask member states to put together their own control plans, taking into account their own situations locally. Nevertheless, very strong messages at the time to strengthen monitoring activities, and this has been seriously taken by Commission with implementation of new legislation in 2013. to develop new antimicrobials. You have also listened this morning to several activities which are being done on this front. It's necessary to develop new strategies to combat the spread of resistance, and I will illustrate some of the examples based on specific risk assessments and to promote prudent use. So the main hot issues that EFSA has treated in the last about 5 years have been methicillin resistance Staph aureus, ESBLs and AMCs, resistance to third and fourth generation cephalosporins, the issue of carbapenemase resistance, and more recently, together with the European Medicines Agency, colistin resistance. So back in 2009, we had an opinion on MRSA. Until that point, MRSA was considered to be only a human problem, a human pathogen. However, at the time, we started seeing MRSA, this large animal-associated MRSA, appearing primarily in pigs. It was quickly apparent that it was not only found in pigs, but also in all intensively reared species, such as veal calves and broilers. The most important transmission route was contact with the live animal and their environments. Therefore, farmers, their families, and veterinarians were populations at risk, and direct consumption of food was not considered to be the main route of transmission. It was also clear from a baseline survey that was conducted around the same time that animal movement and contacts between animals are important factors for transmission. And the advice given at the time, which is also valid today, is that for controlling the emergence of and the transmission of LA, large animal-associated MRSA, livestock-associated MRSA, sorry, the general control options on farms, slaughterhouses, and food production areas are still the only things that we could recommend. In the case of healthcare settings, in human hospitals, MRSA can be effectively managed by screening and infection control measures, and some countries have been really successful in controlling this problem. And in the case of transfer from pets to humans, this is very difficult to control. It's primarily pets are colonized by the same human strains, and basic hygiene measures were thought to be the key. The second hot topic that we treated was ESBLs, AMCs in food and food production animals. And here we identified and ranked possible control options. It was clear that to control the emergence in food-producing animals, the advice given was to really restrict the use of these type of drugs. And the message given at the time is the more stringent the measure implemented, the more impact it would have in stopping the problem. So there is obviously an array of different possible alternatives, from stopping all uses of third and fourth generation cephalosporins in animal production, which is possibly not feasible, to restrict their use and only to allow use under specific circumstances, strong message sent to control off-label use and to make it clear on when this off-label, this cascade can be applied. And overall, a major effort should be made to decrease the total antimicrobial use. And this is due to the fact that most of these resistant microorganisms with ESBLs and AMCs are also co-resistant to a wide range of other antibiotics. So things like tetracycline, very commonly used, could be indirectly selecting for these populations once they are established. In case of controlling dissemination, once the problem is there, the increase of farm biosecurity, implementing of controls on animal trade, of carrier animals, and improving hygiene through the food chain were the main measures identified. And it was deemed to be of high priority to reduce the selection pressure, to prevent vertical transmission from the top of the pyramids, and again at the time, poultry production was the main sector concerned, and after that, poultry industry made quite a huge effort into improving practices, and I think this has been also seen in recent results, as well as to prevent local recirculation within subsequent flocks. More recently, the issue of carbapenemase resistance appeared. Carbapenems are really one of the most valuable drugs to use in the treatment of complicated gram-negative human infections in hospitals. And Suddenly, as an incidental finding in Germany, a few E. coli and Salmonella strains were found containing acquired carbapenemase resistance genes. And up to now, there are no reports of microorganisms with these enzymes in food. Transmission through the food chain has not been reported in Europe yet, although there are recent papers showing this happening elsewhere. And is considered to be likely if this emerges, looking at the history of what happened with ESBLs, things like CTXM, which is now widespread in animal populations. The message was that specific targeted surveys are needed at the European level to really understand the problem, and this was again taken by legislation. Now we screen for carbapenemase resistance in a harmonized way across all member states in Europe, and more so, we have also a specific surveillance exercise with more sensitive, selective methods to try to really detect the problem early on. And a very strong message was sent also to have measures to prevent the emergence and to minimize the spread that need to be in place in member states before they detect the problem. In other words, you should have contingency plans in case something is found in a farm and suddenly you are left with no legislation and with doubts about what to do. It was a very strong message that since these are very rare events and we are probably at the very beginning of a possible epidemic curve, early intervention is crucial to stop dissemination. Moving on with the issue of colistin resistance. Again, colistin resistance is a drug that is used and has been used very commonly in the treatment of animal infections. And it was for quite some time not given too much attention in human medicine because of all the problems with toxicity. The problem is that once emergence to things like carbapenems appears, then the medical doctors are left with absolutely no options to treat infections. Therefore, this drug became, again, very important in the human domain. There was, back in 2013, a mandate sent to EMA, to the CVMP and CHMP, in which EFSA also collaborated. And one of the strong conclusions there was, as soon as colistin resistance are found on mobile genetic elements in the bacteria of concern, then a new risk assessment would be required. So at the time, in 2013, colistin resistance was seen to be just a chromosomal resistance problem. And very recently, in 2015, there was the description of this MCR1 gene reported in human and food isolates in China, and this prompted to a reopening of the whole discussion about colistin. A lot of people started looking back in their collections to see if really MCR1 was a recent problem or if it was something that, because we didn't know, simply we didn't look for, and this was the case. Basically, all these retrospective surveys have shown that back to 2010 or even earlier in their collections of E. coli and Salmonella, MCR1 was already present there. So the main recommendations of the recent EMA report, again to which EFSA participated providing the data from the harmonized monitoring, was that all countries should strive to reduce the use of colistin in animals to the minimum feasible. And there was a clear recommendation to establish targets for those countries with high and moderate consumption. Because again, as you've seen in previous slides, there is a very diverse situation in Europe. There are countries that barely use colistin at all, other countries that are very heavily using colistin. So there was a suggestion to establish a target of 5 milligrams per PCU, population correction unit. This takes into account the size of the different animals, and a desirable target of 1 or below 1 that were proposed. The message was that this should be achieved in a period of 3 to 4 years, and that one should not restrict the use of colistin but return to use other antimicrobials. This should be done without an increase in overall consumption. This is a very important point. and that more information should be gathered to determine what is the absolute minimum level of colistin that can be achieved while maintaining animal health and animal welfare and preventing the increase of use of other critically important antimicrobials such as fluoroquinolones. Right now we are working together with the European Medicines Agency on an opinion that looks into what can be done to reduce the use of antimicrobials in general and the need to use antimicrobials. We are very close to completing this work. It will be presented for adoption from the 2 different committees in December. And I cannot tell you very precise conclusions. It will not be a revolution in the sense that there is no magic bullet for that. I think that the recommendations will be that an integrated approach with emphasis on several aspects across the farming systems, vaccination, etc., should be really attempted, and that the small bits in different parts of the problem will probably have a considerable impact in reducing the need to use these substances. We have been asked within the terms of reference for this particular mandate to look at what member states are currently doing already to reduce the use, and we have several examples of several member states like the Netherlands, Denmark, and some of the Nordic countries, and to evaluate what has been the impact of this reduction in the resistance levels. We have been also been asked to review the alternative measures that one can put in place, equally to assess that impact, and finally to recommend a list of options with pros and cons of each one of these. Another mandate which is ongoing and again will finish now in December 2016 is this risk assessment on the development of resistance due to the feeding of calves with milk containing residues of antibiotics, this waste milk, which again it seems to be a problem in quite a large number of member states. So we have received, the Commission put together a questionnaire that was administered to member states. We have been reviewing the answers, having a close look to farming practices, to the levels of residues found in colostrum and waste milk, and then to see what the impact of feeding young calves with these products is in the emergence of resistance. And we will be recommending also some options to mitigate the risk. So with this, I covered the part on risk assessment, and now I will concentrate a bit on the monitoring and surveillance activities. And why do we want to monitor and survey? First, we want to be able to detect things early on, so we want to detect the emergence, and we want to understand how things are disseminated. We need all this data for the risk assessments, for all these activities I presented before. And we also need to measure the effects of any intervention measures that the Commission may want to put in place. To that purpose, we have also received very recently, again, a joint mandate with EMA and ECDC on putting together epidemiological indicators to be able to measure trends, to see if any efforts that we are putting in controlling this problem can be measured over time, and if we see an improvement of the situation. So again, towards the last quarter of 2017, we will have a list of indicators to that respect. Every year we produce what is called the European Union Summary Report on AMR that gathers all the information from the implementation of this new law in 2013. And we have information on human cases of Salmonella and Campylobacter, and in food-producing animals we monitor again Salmonella and Campylobacter, also indicator E. coli, and involuntary basis Enterococcus faecium and fecalis. And also some member states are continuing to send data on MRSA, although this is not compulsory, it's done on voluntary basis. I have here very, very succinctly some of the points from the 2014 report. We are currently finalizing the analysis of the 2015 report, so I cannot give you the data for that. But in a nutshell, for the data from 2014, which was the specific focus of that year is poultry, there is a rotating system by which every 2 years the same species will be monitored. So now we are working on cattle and pigs, and the data from 2014 was from poultry. Main messages: very frequent resistance to fluoroquinolones observed, low resistance to other critically important antimicrobials, mostly third and fourth generation cephalosporin, and low co-resistance to quinolones and cephalosporins was found. Low occurrence of ESBLs and AMCs, no carbapenemase producers, and it was the first time that carbapenem resistance was surveyed for. And there was colistin resistance also found. I have to say that in this first report, the member states were not obliged to perform the specific monitoring on ESBLs and AMCs, which is compulsory this year, and that uses, as I mentioned before, more sensitive methods to be able to detect the presence of this resistance. So possibly in the 2015 report, we will have data which is more specific to this problem. There was very marked variations between different Salmonella serovars. The beauty of the new system is that we received isolate-based data, not aggregated data as it was the case in the past. So we can perform a lot of more sophisticated analysis at the isolate level, such as multi-resistance. And that there are two serotypes, Infantis and Kentucky, that seem to be driving the overall numbers on multi-resistance in Salmonella. And also, as mentioned several times today, there is a huge difference between reporting countries. And in general terms, there is higher resistance in Eastern and Southern European member states. Due to this isolate-based data, we can now be very precise, and due to the wide number of antimicrobials that are in our harmonized panels, we can really tease out the phenotype to infer what type of genes are behind the observed resistance. So we can, in the case of ESBLs and AMCs, we can really tell what percentage is due to one, the other, or to the coexistence of both mechanisms. And as you can see on this slide, important is not to have the precise data, is to see that we do this at population levels. So we do it in laying hens, in broilers, and in turkeys, and we can really depict what percentage of the phenotype is due to each one of these mechanisms. Again, for colistin, it was the first year, 2014, where we had the harmonized monitoring, and this is a summary of the results obtained. So this is phenotypic resistance to colistin. We didn't look at the presence of the MCR1 because there is no harmonized surveillance for the genes which are behind the resistance in Europe. And you can see there that for different populations and different bacteria, there are different levels. And in general, these were low levels of resistance. But this provides a very good baseline to continue to survey and see if there is a progression towards increasing of this resistance. We are right now working on the 2015 data. As I mentioned, pigs and veal calves will be the focus. We will, as usual, analyze the occurrence of resistance, but we will do further analysis on temporal trends, on multi-drug resistance, on co-resistance to critically important antibiotics. And also, we will be, for the first time, looking at results from this specific monitoring, where there is a specific sampling plan design with a critical number of samples that should be taken and a protocol which was put together by the URL that member states should follow. The new report will be published early in the year, towards the end of January, beginning of February. Another thing that we have done is, now that we have all these very nice efforts into collecting data, not only on occurrence of resistance, but also data on how much the levels of consumption, not only in veterinary sectors, but also in human sectors, it was the time to put all this together. So back in 2014, 2015, we had a joint mandate again with ECDC and EMA for this joint analysis of resistance and use data, and it was done using all data, so it was not data coming from the already harmonized monitoring that we have nowadays. So it was the first time that something like this was attempted. Nevertheless, it was a very good learning exercise to put together methods and to start thinking about the potential problems. And you have there on the slide all the different networks that collect this type of data in humans as well as in animals. From this first report, we managed to put together data on consumption in humans and animals that can be compared across, and it has to be taken with a bit of caution, obviously, because this is not a universal truth, and as you can see there, the level of use in animals is higher than in humans, but this really depends country by country, so you have to look at the small print below. And what is important is that for the first time we were able to do some correlation analysis, and it was clear that in some of the microorganisms and some of the antimicrobials, there was a positive correlation between consumption of the drug in food-producing animals and the levels of resistance in human pathogens, human bacteria. We are now embarked in the second GIACAR report, so we have a joint working group, and we are now working steadily on the plan of analysis. The idea is to present this for consultation to the different networks in April, and it will be published by June 2017. And just the last words I want to say is that we made a huge effort into explaining all of this. So we have been very active in having press releases and press activities, calling journalists to try to pitch interviews, to have opinion pieces in selected papers, to perform joint media relation activities with our sister agencies. We have recently also launched a mini insight survey with consumers and veterinarians in a number of member states in Europe. We have a number of videos that have been published recently. We are also engaging in Twitter chats and social media every time there is one of these documents being published. And for the first time this year, we'll also have a new infographics and a nice tool to be able to navigate in the data from the USR. So not only the report will be there, but we will have an interactive tool that will allow users to really look for the data they are interested on. So we are committed to detect emerging risks on AMR. We put a lot of emphasis and effort in interagency collaboration. We know that this is an integrated effort and we cannot do things alone. We try to support our risk managers to decide on the best strategies to apply and to give a measure on the implementation of possible control options. And I cannot stress how important it is to have this good and harmonized data monitoring system, and how thankful we are to member states for the huge effort they are putting into providing this data to us. And with that, I finish my presentation, so I'll be happy to answer any questions.